there are 5 basic integration formulas. In these formulas, u and v are differentiable functions of x, and the letters a, n, and c are constants. Now, in this video, let's understand first on how to evaluate the following formula of basic integration. Now, in our first formula, it gives us the concept of integrating a constant. Notice that the integrand here, or any constant values, will have a resulting function of its variable itself. In this case, we are integrating in terms of u, thus the integral of du is equal to u plus c. Now, in our second formula is what we call integrating the sum and difference of a function. The distributive property can be applied here. Make sure that each term is separated by either plus and minus. Then we can rewrite the integral function by distributing the integral sign on each term. Thus, we will have the antiderivative of our second formula is the integral of u dx plus the integral of v dx. Now, what if there is a constant pair to a function? We can apply the first formula and rewrite the integral function by taking out the constant outside of the integral sign. Thus, the antiderivative of our integral function is equal to a integral of u dx. This formula is what we call the integration of powers. This rule is what we've used in our previous video. Now, the technique here is to add 1 on the power and take the reciprocal of the resulting power, and then multiply its term. This rule is only applicable if the n power here is not equal to -1. Now, if it is equal to -1, then we'll be using this next formula. The integral of du over u will result in the natural logarithmic function of u, and if you want to check your answer, you can always take the derivative of it. We can prove this formula by taking the derivative of the resulting integral function, but that is on the other video, so check it out. Now we have here a combination example so that we can apply those basic integration formulas. You can pause this video and answer the question. And now, by applying the sum and difference formula by distributing the integration of each term, we have the integral of 5x4 dx plus the integral of 3x squared dx plus the integral of 6 dx. Notice that on each term they have a constant function that is 5, 3, and 6, and we can take this it outside of the integral symbol. Thus we will have 5x4 dx plus 3 integral of x squared dx plus 6 integral dx. On the first term, we can apply the integration of powers by adding 1 on the power itself. So, in this case, we have 4. Adding 1, we will have 5. And taking the reciprocal, the 5 outside will be cancelled out. The resulting antiderivative of this term will become x to the power of 5. Now, same process with the second term. Adding 2, we will have 3. Taking the reciprocal, 3 here will be cancelled out. So, the antiderivative of the second term will become x to the power of 3. And the last term, applying the first formula, this is a constant. This is a constant of the integral of dx. Thus, the resulting antiderivative will become plus 6x. And don't forget plus c, because we are dealing here with an indefinite integral. Now we have here a combination example. You can pause this video and answer the question. This kind of problem can be solved in 2 ways. By using the basic integration and by using substitution. But Here we'll be explaining the method of using the basic integration, and the another method we'll be talking it on the next video. Now we can solve this by evaluating the two products using FOIL method, and that will become bx plus 4 multiplied by 3x plus 4. Taking the first term, we have 9x squared. Taking the outer term, we have 12x. Taking the inner term, we have positive 12x. Taking the last term, we'll have positive 16, and simplifying, we'll have 9x squared plus 24x plus 16. You can use the shortcut method since this is an example of special product, that is a plus minus b squared is equal to a squared plus minus 2ab plus b squared. You can use this formula. We can derive our integral function, that is the integral of 9x squared plus 24x plus 16 dx. You see, we can take the integral of each term without showing in the board distributing the integral function. So we can apply the following term using the integration of powers. For our first term, we'll have 9 over 3. Since the 3 is the reciprocal of the power that is added by 1, so multiplied by x to the 3 plus 24 over 2x squared plus 16x. Simplifying, we get 3x cubed plus 12x squared plus 16x plus c. There's a plus c here. Now we have here a combination of example. You can pause this video and answer the question. In this case, we can derive the equation into the integral of x. This is an example of a special product using this formula. A plus b squared is equivalent to a squared plus 2ab plus b squared. So our a here is x, so x squared x squared raised to squared is x4 plus a is x squared and b is 1, so a times b will become x squared times 2 is 2x squared, and our b here is 1 raised to squared, still 1 dx, and distributing the remaining x term outside the parentheses, we'll have the integral of x5 plus 2x cubed plus x dx. Evaluating the integral of each term, we'll have 1 the reciprocal of the power 1 over 6 times x to the 6 plus 2 over 4 x raised to 4 plus 1 over 2 x raised to 2 plus c. Simplifying our equation, then our final answer will become 16x6 plus 1/2 x4 plus 1/2 x to the 2 plus c. You can check your answer by taking the derivative of our answer, that is, the derivative of this term is x6 will be cancelled out, then x to the 5 plus 4 divided by 2 is 2x to the 3 plus x to 0. you can check that your answer is correct by checking using the derivative. Now we have here another example. You can pause this video and answer the question. Since the given integrand is an improper fraction, we need to simplify it first by finding the factor of our numerator. The factor of x cubed minus 8 has a factor of x minus 2. Using synthetic division, we have 2, 6, 1, 0, 0, 3, negative 8, bring down 1, 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, 0 plus 4 is 4, 4 times 2 is 8, 8 minus negative 8 plus 8 is 0. Thus the factor of x cubed minus 8 has a factor of x minus 2. Then rewriting the equation, we'll have x minus 2, and this term will become x squared plus 2x plus 4 all over x minus 2 dx. So we can cancel this out. Now our remaining term will become x squared plus 2x plus 4 dx. And evaluating the integral on each term, our answer will become 1/3 x cubed plus x squared plus 4x plus c. Now we have here another example. You can pause this video and answer the question. By using FOIL method or using the formula of the special products, then the equation can be rewritten into its expanded form, that is the integral of 1 minus 2 over z plus 1 over z squared dz. Notice that we can also rewrite the function in this form, 1 minus 2z plus z raised to negative. Now, applying the integral on each term, we'll have the integral of constant is z, since we are integrating in terms of z. Notice the second term, we can use the last formula of the basic integration. This will result to 2 the natural logarithmic of z, and using the integration of power, since this is a negative 2, by adding 1, our reciprocal will become 1 over negative 1 multiplied by z raised to negative 1 plus c. Simplifying the answer, we'll have z minus 2 ln z minus 1 over z plus c. Hence, this is our final answer. Now we have here another example. You can pause this video and answer the question. By expanding the factors of the denominator, that is the integral of dx 25 minus 20x plus 4x squared. Further understand, you can rewrite this into this form, dx over 25 minus dx over 20x integral of 1/4 x raised to negative 2. The first term is the integral of the constant, thus this will become 1 over 25x, and the second term is the example of our fifth formula, that is 1 over 20 the natural logarithmic of x, and this will become negative 1/4 x plus the power of x here will become negative 2 plus 1, that is negative 1. So taking the reciprocal, since is equal to 1 and there's a negative sign here, so that will become the positive will become negative multiplied by 1/4, and x here, the x will become negative to the power of x to the power of -1, and that is also equivalent to 1 over x. Thus, our answer is -1 over 4x. So that will be all. So see you around in our next video. Thank you.